Hey guys, this is Ryan, the Geeky Veep, and today I'm going to show you how to use Power BI and R to do a Monte Carlo analysis. It's really cool, so stick around. I think you'll like it. Okay, so if you've ever done a Monte Carlo analysis or simulation, basically you're trying to take randomization and apply it to some kind of model. You want to do it as many times as possible to see what different kind of results you get. So I'm going to show you how to use that. And in this instance, I'm going to use an example here where we're going to do a promotion for credit cards. Okay, so my CEO has come to me and he wants to run a promotion. And so basically what it is he wants to see an increase in usage for credit cards. And he believes that if he pays $100 to every card that increases their usage by a certain percentage, then he'll pay them, but more often than not, people will not meet the limit, but they will still increase their usage. So here's how this works. I'm going to kind of show you a real quick example here. The number of cards that transact, we're going to use 150,000. And how much do they transact every month is $75. So you take that 75 times 12 to get, the total that they would spend all year. And then we have something called an interchange rate. Okay, and this is the amount that this company or this bank would get for, you multiply that by all the transactions, and that's the income that they would get. Okay, so we have that, and then we're expecting the average increase of usage to go up by 50% per card. Okay, and of those cards, only 5% are going to meet the minimum, and we're going to pay those cards $100. Okay, so if that makes sense, let's go on to show you what the results would be. So prior to the promotion, what you're doing is you're taking, so we have A, B, C, D, E, and F. You're taking the number of cards times their usage times the interchange rate times 12. Okay, when we do that, we expect to earn, if we don't do anything, 2.4 million, right? Okay, but then what happens when we do the promotion? So we have the same thing again, what they would have done, times 1 plus D, and D is the expected increase. So that's the increase, okay? But then you have to subtract out how many cards are we paying that $100 to. So minus the number of cards times the promotion cost times the number of cards that would meet that minimum, okay? So even after all that, we see that we have like a 2.9 is going to be our results after the promotion. So 2.9 minus the 2.4, and that gives us around $500,000 increase, $465,000 to be exact, okay? Now, that sounds great, okay? But the problem is you are using one expected value for every single variable, and that can get you into a lot of trouble. So what you want to do is give your CEO, here's the most likely outcome, $465,000, but there's also a likely outcome that we could lose money or make a lot more money. So your CEO says, okay, I get that. So he's going to give you a couple of goals here, and we're going to go through that. The first one is he wants to make sure that you're 75% certain that we'll make at least $200,000. Okay, that's a lot less than what the expected increase is, but he wants to make sure we at least make some money, and his threshold is $200,000. Okay, the second goal is going to be, all right, well, I also don't want to lose any money, right? So he wants that percentage or the probability of losing money to be less than 5%. Okay, we need to be able to tell him that. What's that percentage? And then the third one is, he just wants to know what's the probability that it's going to make between, a couple of dollars. What's that range? So his range is, as long as it makes between 100,000 and 400,000, just give him that idea of what's that probability. All right, so how do we do this? Let's go over to R. Okay, and I should tell you this, I'm not a data scientist. I'm not an expert in R at all. But I've just, from the little bits and pieces I've picked up, I found this really cool way of doing this analysis. So the first thing we want to do, and I've already got it laid out here, is we want to create the variables, okay? We're going to define the variables, and we're going to use something called R norm, normal distribution. And this might not be the right distribution for all of these variables, but we're just going to use it in our example today. So remember our variables. We have the number of cards. So the number of cards would be R norm, okay? And I'll just retype it, cards 2, okay? And you're going to define a variable. You always have to do a little arrow like this. We're going to do R norm, okay? And then within the brackets, you tell it how many trials you're going to do. So we're going to do 1,000,000 trials, okay? Then you have to tell what the mean is, okay? And I said 150,000. And then the standard deviation, okay? So we think that, you know, there's a 68% of cards will fall within plus or minus 5,000 of that 150,000, right? Okay, so I'm just going to quickly get rid of that. And that kind of explains how each of these works. We have our cards, we have our usage, which is $75, and a standard deviation of 10. So one standard deviation says that cards are going to go through $65 to $85 worth of transactions each month, as opposed to just saying $75. We have the rate, that's the interchange rate, again, 1.8%, but we've got a standard deviation of 20 basis points. What's the promo cost? It's going to be $100 no matter what, right? So if you make the minimum, it's $100. There's no distribution there. It either is or it isn't, okay? Then the increase, this is the increase in the usage, okay? We said it would be a 50% increase, standard deviation of 10%. The minimum is that the percentage of cards that meet the minimum is going to be 5%, and again, a 1% standard deviation. Okay, so there are all my variables. And then we're going to set up what the income would look like prior. So remember, it's cards times usage times rate times 12 for 12 months. What would it be after the promotion? Same thing, times the increase, okay, minus what it costs us. So the number of cards that meet the minimum, so cards times minimum, times the promo. Okay, hopefully you're following me here. It's really basically, it's algebra here, but it's really kind of cool that you can do this within R. So then the final variable I have here is what is the income after, okay, and then what is the income prior. Okay, so to run any scripts that you have in R, you can go to a line and you would hit Control Enter, or you can highlight everything and hit Control R. This last line here is a line that I use to, it's going to put it into this folder here. And I've already done it, so I'm going to go ahead and delete this file. All right. And it will create this file for me. It'll automatically export it for me. So what I'm going to do is I'm going to highlight everything. All right, I'm going to have it run all this by hitting Control Enter. Give it a couple seconds, and boom, if you saw that, it automatically placed it out there for me. Okay, so R, we're done with R. We have our analysis, a lot of different trials. Okay, and now let's go to Power BI. I've already set this all up, so this time I'm going to go ahead and hit refresh. And remember, I've got 1,000,000 trials. So all those variables, standard deviations, expected values, and it goes through 1,000,000 different ways. So if you look at this distribution, this is the most likely outcome right here. We're talking about right around 464,000. Actually, if you look at Excel, we thought it'd be 465,000. And according to Power BI, it's pretty much right there, almost 465,000. But look at this distribution. There's a good chance that you're going to lose a lot of money here, right? Or a good chance you're going to make a good chunk of change, right? So we want to really understand that. Okay, so I'm not going to show you how I did this, but I connected to that CSV file. I pulled it in, and then I made a few DAX formulas to help me get through this. And one little tip I have for you. So here's my CSV file, the data set that came in, and in that I have a result, which is the, how much the increase I'm going to make. I have the number of trials, and then I put it into bins. So I did the grouping. I did a new group. I'm going to hit edit group so you can see what I did. All I did was I wanted the bin type just be the number of bins and 200 count. So that just means put it into 200 different bins. It just makes it look a little bit better. Okay, now that I have that, here are the DAX formulas that I use. The first one you want to do is how many trials. Okay, we use count A just to count the number of trials. Okay, and that number is going to change as I change this filter here. This filter, and I'll create another one here real quick, is basically just taking the filter and putting the result into it. So you can change that, okay? I'll delete that one, and we'll go back up to that filter. So basically I'm saying the results can be anywhere between $950,000 loss to $2.6 million in income. Okay, so that's a wide range. We have the ability to adjust this and see what the outcomes would be. Okay, so I have the number of trials again, and that changes as I change the results. Notice by going from 500,000 to the max, now I went from 1 million trials to 428,000 trials. Okay. The next thing I want to show you is this formula here. This is all trials, and all this is the same thing. I'm using the number of trials, that measure I just created, and using the all function so that no matter what my result is here or how my filter is laid out, I always have 1 million trials. Okay, and here's why it's important to do that. It's important because then I take the percentage of trials, which is the number of trials divided by all trials. Okay, and that gives me an idea of what the probability is. So as I want to look at, remember goal number 1, what is the certainty that he'll make at least $200,000? We can come up here to our filter, change the number 200,000, and right there we see that 76.49% of our trials will make us at least $200,000. So we can go back to the CEO and say, yeah, there's at least a 75% chance, 76%. So it's not, that much over your threshold, but yes, it'll make that. It'll make your threshold. Okay. So you get where I'm going with this? Now, if I remove that filter, you could see again the average result, almost 465,000. So then let's look at the other goal. There must be less than a 5% chance of losing money. Okay, so if we come over here and hit the max of 0, hit enter, there's actually an 8.78% chance that we're going to lose money on this deal. All right, so that does not pass the test. Okay, so you could say, yes, it passes test number 1, does not pass test number 2. And the final goal is he wants to know what is the probability that we'll make between 100,000 and 400,000. So again, we come up here, enter our dollars. Oops, I need to change this so it'll accept the 100,000. Put that in as a minimum and 400,000 as the maximum. All right, you go back and tell them, look, there's a 30% chance you're going to make between 100,000 and 400,000. So that's pretty good. All right, well, what if it's between 100,000 and 600,000? There's a 50% chance you're going to be in that range. So that's pretty good. So anyways, you can go back to him. You could have lots of different goals you're looking for. But the main thing is you want to be able to tell him, well, look, your expected value is going to be that $465,000, but reality is there's a lot of variability here, and you need to know what the impact could be from that variability. Okay, so anyways, hopefully you found this video of value. Try it out yourself. Try R. If you haven't gotten into R yet, I highly recommend it. There's a really great course that I highly recommend. It's on Udemy. If you've ever used courses there, and try I think it's called R Programming A to Z. And the guy who gives the class is Kirill Eremenko. And he took me from knowing zilch about R to being able to do things like this and being able to do a little bit of damage, I mean, I'm having fun with it. Definitely not an expert, but this is very impactful stuff. So anyways, guys, I'll see you at the next video. Bye.